Yes. Yes. Yep. Okay. Let's go ahead and go into today's lesson. This kind of builds on what we did with the first half of the chapter. So we're still kind of doing all the same stuff. We're just going to kind of add to it. So what we're doing today is the fundamental theorem of algebra, which you guys already know. Rational zeros, finding rational zeros with the rational zero theorem. That might be something new for some of you guys. And then zeros of polynomials by factoring, we already know how to do that. So we're going to take some skills that we already know how to do and combine them with some new stuff. So first of all, fundamental theorem of algebra. That just means, we already know that. That just means that if we have an x to the fourth power, then we're going to have 4 solutions, right? We already know that one. And then the linear factorization theorem just tells you how many, if you were to factor it out, you would have the same amount of factors. If you could factor it, if it was to the fourth, you could factor it to 4 parentheses kind of thing. So really quickly, let's go through these and figure out how many zeros and what are they. So if you're going to find zeros, remember you're going to want to have it equal to 0 because you're solving for x. So you have 0 equals x minus 2. So that, because that's a degree 1, there would be 1 0. And what is it? X equals what? 2. Yeah. Okay, then here we've got x squared minus 6x plus 9. This one should have 2 zeros. But when you factor it, what do you notice about the 0? Yeah, it's the same. So x equals 3. So this one is, if you get a repeat, what was that word that we learned for repeats that in the first chapter? It starts with an M. Multiplicity. So this is a multiplicity of 2. We still have 2 zeros. That one just has a multiplicity. So this one is an x to the third. So that would mean 3 zeros, right? Okay, factor that. So we're going to take out the x. And then we end up with x squared plus 4. And if you continue to factor that one, it turns out that you end up with x, x plus 2i, and x subtract 2i. So the zeros on this one are x equals 0 and positive and negative 2i. So one of the zeros is a real, and the other 2 are imaginary. So this test question came up on the test, and it asked, the one thing you got to remember about imaginary numbers, and I don't know that I stressed this, but I kind of just assumed that you guys all knew it. Imaginary numbers always come in pairs. You'll never have a single imaginary number. If it's a solution, if 2i is a solution, it's conjugate pair a solution. So 2 and negative 2i, always. If 4 plus 5i is an answer, then 4 minus 5i is an answer. Imaginary numbers always come in conjugate pairs. Okay, and then the last one, x to the fourth minus 1. That's 4 zeros. So when you factor it, that's x squared plus 1, x squared subtract 1. And if you keep factoring, or you could solve it, x plus I, x subtract I, x plus 1, x minus 1. So all of our zeros, we have positive and negative 1 and positive and negative I. So there's our 4 zeros. So we can find them whether they're real or imaginary. You should be able to find all of the zeros that go with a polynomial. Okay, so now this is the new part. So I don't know if you guys have done the rational zero test before. So what the rational zero test says, if you take all of the, you know how when we do factoring and we do guess and check and we do the factor pairs of the n number and the factor pairs of the first number? Okay, this is what, they call it p divided by q. So these are the factors of the n number divided by the factors of the leading coefficient. So it's everything on the end divided by everything on the front. So what that tells you, and it's kind of helpful with our graphing calculators, a lot of this is taken away because we can look on our graphing calculator. But if you don't have a graphing calculator, so like in 1050, when they don't let you have a graphing calculator, this is really helpful to get started in a synthetic chart, because you got to figure out what to put in your chart. And if you don't have a graphing calculator or any other information to figure it out, this is a good way to figure it out. So what you do, so the P divided by Q would say this. What all the factors, so one is really easy. This is 1 times 1, and then this leading coefficient here is 1 times 1. So it's all the factor pairs of P divided by Q, but you do the positive and negative. So basically what we're saying is plus or minus 1 divided by plus or minus 1. So really, I would just write it like this. That's going to be your choices, okay? So that's how you find the rational zeros. Now, what the rational zero theorem tells you is this. If you run 1 through a synthetic chart and you get a 0, that'll be an answer, okay? Or if you run -1 through a chart, and you get a 0, it'll be an answer. So if the 0 is a rational number, it will be a factor of P divided by Q. Okay, now if the 0 is an irrational number, like a square root or or an imaginary number, this won't help you find it. P divided by Q won't help you find it. So P divided by Q only helps you find the rational zeros. So it'll help you find the zeros if they're integers and even if they're fractions. We don't have any fractions here because this just turned out to be positive or -1. Okay, so if we run it through a chart, so let's run it through a chart. So we can pick 1 or we can pick -1. Which one do we want to pick? Doesn't matter. -1. Okay, if you take -1 and you run it through your synthetic chart, remember to put a 0 in for your x squared. So -1 times 1 is -1. Add straight down. 1, 2, -2, -1. Okay. You didn't get a 0 on the end, so that means -1 is not a rational solution. -1 doesn't work. If you plug 1 through, so 1, 1, 2, 2. Once again, you did not get a 0 on the end, so it's not an answer either. So what that told me was that this problem right here does not have any rational zeros. X to the third plus x plus 1 does not have a rational zero. It's got to have an irrational zero. If you look right here, here's the graph of it. So pull up your graphing or get out your graphing calculators and type that equation in. So we're going to type in x to the third plus x and plus 1. And then we'll graph it. I guess I'll hit my zoom 6 so I can see what it looks like. So you can see that it's crossing right here. And you might think, well, maybe that's a fraction. Maybe that's like negative, I don't know, 3/5 or something. It's not, because we did the rational theorem test, and if it was going to be a rational number, we would have been able to find it. So if you go to your calculator and hit 0, so second calc, and we'll go hit 0. And then left bound, right bound, just go on either side. And hit enter. That's the 0 right there, 0.682328. That's what it is. So it's not a fraction. It's not like 6/10. It's some radical. We don't know what it is, and we don't have the skills right now to figure that out. So we just go with our graphing calculator, okay? So let's try it again. So we'll do the next one here. So this one says find all of the rational zeros. So you want to start with the rational zero theorem first. So rational zero theorem says take all the factors So basically our factor pairs of 6 are 1 and 6, 2 and 3, right? So we're going to take all of those and divide them. So this is what we call P divided by Q. And we're going to divide them by the factor pairs of the leading coefficient, 1. So I just always go plus or minus because it could be a positive 1 or a negative 1. We don't know the combination. And then I'll just put them in order. 1, 2, 3, and 6 divided by a 1. So what that means is, what it's telling you is that if you have a rational 0, it's going to be positive or negative 1, positive or negative 2, positive or negative 3, or positive or negative 6. Okay? So it's kind of cumbersome. If you don't have a graphing calculator to help you out, you have to guess. Like, which one do you want to guess? 1, 2, 3, 6 or negative 1, 2, 3, 6? I don't know. Are you a good guesser or not? So let's pick one. Pick one for us, Josh. Negative 3. We're going to run it through our chart. Now we're going to learn some other things that help us when we run it through our chart to know if we have a good guess. Okay. So that first one is a good guess. So we're going to run it through our chart. So negative 3 times 1, so negative 3, negative 4, 12, 13, negative 39, negative 42. What is that going to be? It's going to be a positive, and then this one right here is 126, so 120. Okay. Oh, perfect. This actually gives us one of our clues. Okay, you guessed negative 3. Now I want you to notice what happened with all of the numbers in our chart here. So when I'm looking at this, this is a positive, this is a negative, this is a positive number, negative, and positive. If the signs alternate like that, it's called a lower bound. Okay, so this is alternating signs. It's a lower bound. So what does a lower bound mean? If I were going to randomly guess another number, what number would not work? I already know it's not going to work. Right. Any number smaller than negative 3 is not going to work. So negative 6 is not a good guess. Don't try negative 6. That's not a good guess. Okay. So we know it can't be below negative 3. So what do we want to try for our next number? Negative 1. Okay. So run it through our chart. So negative 1 times 1 is negative 1. That'll be negative 2. So positive 2. That'll be 3. Negative 3. Negative 6. And then we got positive 6. And then a 0. Yes. Okay, so one of our answers is negative 1. Now, when you look at the polynomial that's remaining, this is x to the third minus 2x squared plus 3x subtract 6. If you can factor this, factor it, and you can do the rest. I actually think that one will factor by grouping. Should we try it and see? If it doesn't factor by grouping, then you need to make another guess. How many zeros are we trying to find, guys? 3 or 4? What was our original polynomial? We're trying to find 4. So we have one of them. So the sooner you can get to something you can factor, the less guessing and checking you have to do, right, through the chart. So let's go ahead and see if this will factor by grouping. So this one I would factor out an x squared, so that gives me x subtract 2. On the back end, I would factor out a 3, so that's x minus 2. So grouping will work. It's x minus 2 and x squared plus 3. Okay, so now from these parentheses right here, I know what all my zeros are. 2 is one of the zeros from the first parenthesis. This one right here, x squared plus 3, when you solve that for x, what are you going to get? I think you're going to get an imaginary number, aren't you? Because when you take the square root of both sides, you end up with x equals plus or minus the square root of a negative 3, which is positive or negative I root 3. Okay, so here's our four answers that we have. 2, negative 1, positive negative I root 3. Okay, out of this list, which ones are considered, what was our question? We got to look at our question. It said to find all of the rational zeros. Out of that list, which ones are rational? Are they all rational numbers? No. Imaginary numbers are not rational numbers, right? So out of this list, the only two that they really wanted was 2 and negative 1. Okay, so those are our rational zeros. Okay, let's go back up here to this chart where we found the alternating signs and we found the lower bound. Let me tell you what an upper bound does. An upper bound, the signs are all positive. So if you run it through a chart and they all turn out to be positive numbers, don't pick a number bigger. That's the top end. It wouldn't be anything bigger than that number, okay? So and if you end up with a 0 somewhere in your chart, if it just follows along with the pattern, then that would, so like if this one right here was a 0, then you could say, because 0 is not positive or negative, right? So if this one right here, this 13, turned out to be a 0, for example, if this was 0, this would still be considered a lower bound because it would go positive, negative. You could count that one positive and then negative. So you can count 0, whatever sign you need it to be to follow the pattern. So if you needed it to be a negative number and it was negative and then it followed the pattern, that's what you would do. If you needed it to be positive so they could all be positive, you could count it as positive. So if you get a 0, you can count that any way you want. Okay, so that's those will help you figure out upper and lower bounds. So the signs when you run it through your chart. And then there's one other trick, and we kind of talked about it last chapter. When you do your chart, and this was on our review, and we run it through our chart. So let's say I run 1 through my chart, blah, 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 and I get down here for my remainder, I get negative 2. And then let's say I run 4 through my chart, blah, 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 and I end up with 6 for my remainder. What do we know about the zeros? Where are they located at? Between what two numbers? Between 1 and 4. There's an answer between 1 and 4. So if your remainder, if the number on the end right here, if you do 2 consecutive things and you see they alternate in sign, then that means there's a 0 between those two x's somewhere. Between 1 and 4, there's a 0 somewhere. So that also helps you narrow down. So those 3 things help you narrow down so it's not a random guess. Okay, so here we go. So we talked about the 0, the p divided by q. We talked about the change in the sign and the remainder. They call that the intermediate value theorem. That was what we just talked about right here with all the, right here, with the blah, 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 checking the remainders. Okay, and then we talked about upper and lower bound. And then, of course, if you're allowed to use your graphing calculator, your graphing calculator is going to be the best tool. So let's take that equation that we just had and type it in our graphing calculator. So let's take x to the 4th and type it in our graphing calculator. And so look, right off from my graphing calculator, I could see that 1 and negative 2 were the two answers, right? I didn't even have to guess and run it through the synthetic chart. If you go to the table, you can see that. Oh, let's go. Um, so there's my 2 and there's my -1. I can see those are both zeros. So then students ask me all the time, they're like, well, then why do we have to do the upper bound, lower bound, the guess, and all of that if you could just look on your graphing calculator? Well, in this class, it's okay to use our graphing calculator to help us. But like I said, when you go to 1050, you don't get a graphing calculator. You have to do it this long way. So it's good to practice both to be able to do both techniques. Okay, let's try the next one, see what it wants us to do. So this one says, prove that all of the real zeros lie between the intervals 0 and 1. So I guess what you're going to have to do is run if you want to prove that they all lie between that, what are our potential rational zeros first? So let's start with that. How do we do that? All the factors of 6 and all the factors of 10. So the P divided by Q is going to be positive and negative 1, 2, 3, 6 over 1, 2, 5, 10. Okay, now let's talk about actually what are the choices when it looks like this. So I don't expect you to write them all out every time, but I am on this one just so you can see how it works. So if you take this 1 and divide them all, then that would mean plus or minus 1, 2, 3, and 6. Those are all choices. Okay, now use the 2. So basically what you're saying is it's 1 over 2, so 1/2. 2 over 2, which is already 1, I have that one. And then 3 over 2. And then 6 over 2, which is 3, and I already have that one, so I don't need to write that one. Okay. Then we're going to move over to the 5. So 1 over 5, that's a choice. 2 over 5, that's another choice. 2 over 10, but what does 2 over 10 reduce to? 1/5, right? And so we already have that one, so we don't need to write it. And now we're going to move over to the 10. So it's 1 over 10. We always do the numerator divided by the denominator, so 1 over 10. Then the next one would be 2 over 10, but that one reduces to 1, we already have that one, right? 1/5. And then 3 over 10, which is, oh, we don't have that one. Did we skip 3 over 5? Oh, did I stop halfway through? Oh, okay, yes, we need 3 over 5 and 6 over 5. 3 over 5 and 6 over 5. And then 3 over 10 and then 6 over 10, but what does 6 over 10 reduce to? 3 over 5, and we already have that one, right? Okay, so, oh my goodness, look at all those choices. Those, I mean, so if you're talking guessing and checking, that is way cumbersome to try to figure out which one of those are the right answers, right? But think if you didn't have a graphing calculator and you had infinite number of numbers to choose from, at least it gets you narrowed down to this, right? Without this, you're totally drawing a blank. It could be any number. So at least this gets it narrowed down, even though this is still all these choices, at least narrows it down a little bit. So those are all our potential rational zeros. So, but really, out of all those potential, which ones should we try? Like, what would be a smart guess to try based on the question I'm asking? Because we want to prove that all the real zeros lie between the intervals 0 and 1. So try 1/2 to see if that, why don't we just try 0, and we want to, you'd want to check, if you want to make sure that they all of the real zeros lie between 0 and 1, aren't we really looking for an upper bound and a lower bound? That's what we're trying to prove, right? So let's run 0 through the chart, and let's run 1 through the chart and see what happens. If it turns out to be an upper and a lower bound, boom, we're done. We know they're all between those two numbers. So this was just, you know, an exercise getting all those rational zeros, choices. So let's run 0 through the chart. 10. Okay, now we're going to have to put some 0 placeholders in, right? Because that's a fifth power. So you need the fourth power, the third power, second power, and there's your x and your -6. Okay, let's run that through the chart. So 0 times 10 is 0. Add that down, you get 0. And 0 times 0 is 0. And 0. And -3. And what do we end up with? 0 and 1 and 0 and -6. Okay, so remember, we could count zeros any sign we needed them to be. To prove it's a lower bound, they have to alternate in sign, right? So this would be a plus, minus, plus, minus, plus, minus. Perfect. It's a lower bound. That proves it. 0 is the lower bound. The signs alternated. Okay, now let's run 1 through the chart and see what happens. So 10, 0, 0, -3, 1, and -6. So 1 times 10 is 10. And then 1 times 10 is 10 again. 1 times 10 is 10. So 7. 7, that's 8. 8, and 2. And look, they're all, what do we have to be an upper bound? They all have to be positive, and they are all positive. So that is an upper bound. So did we prove that all of the zeros are between 0 and 1? We sure did. So out of our potential list, the only ones that could work are all of the fractions that are between 0 and 1. That's got to be one of our rational zeros. So let's type that in our graphing calculator and see what it is. It's right there. That's the picture, but let's type it in our graphing calculator. The original, and see what it is. Let's see if it's a rational zero. Maybe it's a radical. I don't know. So let's type it in our calculator. Oops, that's the fifth. Okay, and then let's do the 0 button and see what it is. So 0.95. 0.95. So that's probably an irrational zero, because that's not any of our fractions, right? Okay, so there we go. But all of our zeros are between 0 and 1, and it's 0.95. So this was x equals 0.95. So it's probably an irrational zero. Okay, so this is kind of what you're going to be doing in your homework and on the test. So this one says find all the real zeros. So you're going to have to set up the chart. So you got to figure out what to start with. This is all I tell you. And does this factor? If this factors, definitely do factoring. Could you get that to factor by grouping? Does 75 go into 125 15 times? If it does, we're in great shape. Probably not. I don't think that factors by grouping. Okay, so it doesn't factor by grouping. So you're going to have to go to your chart, your synthetic chart, and try to figure out a number. Well, I actually don't know what number I want to use yet. So let's do 1, -15, 75, and -125. Okay, for the sake of time, type that into your, because our choices are all of the factors of 125, right? 125, 1 times 125, so we have positive -1. And 5 times 25, right? What else goes into 125? Is that it? that would be our choices. If it was a real number, a rational, let me get the right qualification. If it was a rational zero, it'd have to be one of those numbers. Type this in your graphing calculator and see if you can find a zero that you can see. Let's just do that. For the sake of time, let's type it in our graphing calculator and see if we can find one. What's the picture look like? Does it look like there's a rational zero that we can run through the chart? You're shaking your head. Yeah, what does it look like? 5. So it looks like it's crossing at 5. Okay, so we'll run 5 through our chart. And this will be 10, and then 50. And then this will be, wait, I got to have an error somewhere because you can't add those two together and multiply that by 5 and get a 0. Oh, I brought a 5. Yeah, you're right. I'm like, wait a minute, I got ahead of myself. I'm like, that is not right. Yeah. Okay. So 5 times 1 is 5, negative 10, so negative 50, 25. There we go. I'm like, you got to get a 0 on the end if it's a 0. Okay, so now you're to this point, guys. This is x squared minus 10x plus 25. So that one factors to x minus 5 times x minus 5. So it looks like to me that the answer is x equals 5 with what? A multiplicity of what? Not 2, it's 3, right? We got to have all of our zeros, and it looks like it's 5 being repeated 3 times. Okay. You guys want to try that one by yourself? See what you come up with. Find the real zeros and see what you come up with. So I'd probably go to the graphing calculator, get something to start with first, or you could do the p divided by q stuff. So this is 1 times 3. So did you go to the graphing calculator? So you can see that you've got a 1 and a negative 3. Those look like things you'd want to run through your chart. And it looks like you've got one right here. Maybe that could be a half, since that was one of our rational zeros. So did anybody run one through the chart? You went negative 3 through the chart. Okay. So when you run that through the chart, what you ended up with probably should have factored. Did it factor? Okay, so then you have 2x squared minus 3x plus 1, and then you factor that, and 2x, x, 1, 1. So we end up with x equals a half and positive 1. So yeah, and look, they're up there in our choices for our rational zeros. Okay, one more, last one, and then that's it. I think you'll have it figured out. So a negative 10x to the third plus 15x squared plus 16x minus 12. So you have all the factors of 12 that could be choices. So if I don't let you use your graphing calculator, guys, which I actually do, but I'll let you use it. If I didn't let you use your graphing calculator, you would have to try all these combinations, which is really cumbersome. So all the p divided by q stuff, that's where you would start at. But graphing calculator is really helpful. So go to the graphing calculator and figure out of all those p divided by q, which one would be a good one to run through our chart. 3, 2. It looks like it crosses at 2. Okay. So then run 2 through our chart. Yep. So then you're left with something that should factor, and if it doesn't factor, because it's a quadratic, guys, the goal is to either factor it or get it down to a quadratic, because if a quadratic doesn't factor, you can always put in the quadratic formula to get the other answer. So that's really what you want to have happen. But factoring is always quicker, so if you can get it to factor. I think I would take out a negative sign. I just like to factor with the leading term positive. So from your graph, what else did it look like was another zero? Was there no more integers? Are these are both going to be fractions? So then if they're both going to be fractions, does it look like, should we try the 2 and the 5? And we want it to subtract to give us 5. So if I did 3 here and 2 here, that'd be 15. Nope, that won't work. 3, nope, that won't work. So those two won't work. 2 and 5. Should we try 1 and 10? And that's going to be too big. 1 and 6, that's not going to work either. Does it look like it's a, do your 0 button and see what it tells us the other ones are. .564. I'm thinking quadratic formula here. Because look at our choices. Our choices are, even if we're talking fractions, it would be like 1/5, 2/5, 3/5, 4/5. None of those are what you said. So this doesn't look like it's going to factor. So we're going to go x equals, we're going to put in the quadratic formula. Personally, guys, I like to work with the leading term positive, so I'm going to put those numbers in the quadratic formula, and you can do that. If you take a GCF out, you can do what's left over. So opposite of b, oh, whoops. And then hopefully we'll get those decimals that you got on your graphing calculator. So opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So -5 plus or minus the square root. What's under the radical? 25 minus all of that. What's that number? I just need the number underneath the radical. 25 subtract 4 times 10 times -6. It's got to be a positive number. What is it? 265. 265. Okay. So let's actually figure out. You didn't write down your zeros, did you? The 1.00 that you got on the calculator? You did? Oh, good. What were they? Those decimals? Okay, let's see if we can actually get those decimals on with our radical. So in your calculator, go -5 plus the square root of 265. Then I would hit the enter button and then divide by 20. Did that match? It's -1.06 and 0.56. It's that one? Oh, good. That makes me happy. After we do all that work. Oh, you want it to match, right? And then to do the other one, go -5 minus the square root of 265, hit enter, and then divide by 20. Okay, so these are actually, so when it's looking for, it says find the real zeros. Your graphing calculator was a great help. The decimal is not the answer we would be looking for. We would want the radical form because that's a real number. Radicals are real numbers. They're just irrational, but they're real numbers. So we don't want the decimals, even though we went to our calculator to make sure we're doing it right. These two answers, and then what was our other one? X equals 2. Those are our real zeros right there. That's what we're looking for. Okay? All right.